Okay, so let's go ahead and do a couple more examples of electron configuration because they can be a little bit tricky. So remember that with our periodic table, they are arranged in order of increasing atomic number. Okay, so one hydrogen has one proton, one electron. Two helium has two protons, two electrons. Lithium has three electrons. Beryllium has four, so on and so forth. So when we're doing electron configuration, it's basically just a way to write the code of like where those electrons are going to fall. Okay, now remember the blocks tell us the shape of the orbital that the electrons are in. So remember that s orbital was a spherical shape, the p orbital is kind of like a figure 8, the d is like a clover, and then the f is like looks kind of like a flower to me. But that just tells us the shape and how the electrons are moving around the nucleus, okay? So when you see like all of the elements in the s block, the orbitals or the electrons in those s orbitals will be around in a sphere shape. All of the electrons that are in the p block, in the p orbitals, they'll be moving in that figure 8 shape. Okay, so basically this is just a code telling us where those electrons will be located and what kind of shape and movement they will have around our nucleus of our atom. Okay, so next let's take a look at just a couple of examples. So I'm going to do magnesium and I'm going to do nickel. So anytime we're writing an electron configuration, we want to first find the element, right? That's the first thing. And then figure out how many electrons it has in it, and then also determine what the configuration is of its position, okay? So here we have magnesium. He's got an atomic number of 12, so I know he's going to have all those superscripts of our configuration add up to 12 because he's got 12 electrons, okay? So what we need to do is we need to first find the period he's in, what block, and then what is his position in that block. And I call elements he's, I don't know, it's just the way I do. Elements don't have genders, but whatever. So he's in the S block, right? Because again, if we just look at our reference, magnesium is in the blue, it's an S block. He is in period 1, 2, 3, and he is the second element. So his final configuration, what's going to be in that last period is 3s2. So I know I'm going to end up with 3s2, okay? And again, that's because magnesium, his period is 3, his block is S, and then he's the second element in that block, okay? That also means that he's got that 2 electrons are in that block, okay, or in that orbital. All right, so this is what we'll end up with, right? But for all full electron configurations, we have to include the configuration of all the elements before because those include all the other electrons, right? If we just put this, that would mean that magnesium only had 2 electrons. It doesn't. We know it has 12. So I'm just going to go back to the beginning and fill in, basically write out all the configurations from hydrogen on, okay? So we're going to always start with 1, okay, and then S block, and then we're filling through. So we're going to make sure all of these orbitals are filled. So each orbital, S orbitals, will hold 2. Okay, well, every orbital holds 2, but the P block has 3 orbitals, so they get up to 6. Okay, so we go 1s2. Then we have to drop back down. We have to go through the S block again. So we're going to fill up our 2s2. So write 2s2. Okay. Then we have to go through our second P block. So we're still in period 2, but now we go over to block 3 and we know we have to go through all these elements. So it would be 2p6. And then finally 3s2. And this is where we stop, right? Because this is magnesium's position, and then we have filled in all the information before. And then we can double check ourselves. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. If you add up the superscripts, it will give you the atomic number, okay? So all those added together gives us 12, and that gives us the atomic number of magnesium, so we know that this is correct. Okay, so that's the full electron configuration of magnesium. So let's go ahead and do nickel as well. So nickel is a transition element. Nickel is right here. Now, nickel is a little bit different because when we start getting into the transition elements, we have to remember that their configurations, their energy level, we have to subtract one, okay? So if we pay attention, nickel is in period 4. But because it's a transition metal, we're going to subtract 1 from his configuration. So he's not going to be in 4, he's going to be in 3, okay? And that's just something that we have to memorize. Again, in your notes, this table is going to be your best friend. If you look right here, it says 3D. So that means that's the level, and then also that D tells us the shape that those electrons in those orbitals will be in. Okay, so that just tells us the movement that they're in. So let's go ahead and figure out what we should be ending up with, and then we can do our full configuration. So nickel is right here. We know he's in our D block, and we now know and remember that he's going to be the 3, not the 4. Even though he's in period 4, because it's a transition metal, we got to subtract 1, right? So we know that we're going to end up with 3D. And then nickel is 1, 2, 3, 4, 5, 6, 7, 8. He's the 8th element in that block. So we know what we should be ending up with is 3, because he's a transition, D, 8. Okay, so now to do the full configuration, we go back and we have to start at the beginning. Okay, so we're going to start at hydrogen and do all my configurations down until I get to nickel. So again, we always start with 1s, because 1 is the lowest energy, and those electrons fill from lowest to highest energy, so it'll be 1s, 2. Okay, so the maximum an S sublevel can have is 2. Then it's 2s, 2. Okay, then we have to go through our P block. There's 6 elements in the P block. The maximum number that the P sublevel can hold is 6. So it'll be 2p6. Then we have to drop back down to our S block, 3s2. Then we have to go across to our 3p. We go all the way through, so it's 3p6. Perfect. And then now we drop down because we're still not to nickel yet, so it's 4s2. So again, that is 4, 4th period, S block, 2 electrons. Okay. Now we have our final, we're getting to nickel, so we're at our transitions, and now we're at our 3D8. And again, we just got to remember for those transition metals, we are subtracting 1 from the period. So it's 3D8. And again, you should be able to add up these superscripts to give us the atomic number of nickel, which is 28. Okay, so you should be able to add those up and get 28. So 8 plus 2 is 10, plus 6 is 16, 17, 18, 19, 20, 21, 22, plus 6 is 28. Okay, so that is correct. So it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d8. So that would be the electron configuration of nickel. Really, unless it was like a challenge question, I'm not going to really give you anything past, like, I would say period 5. Because, you know, when we start getting into like the F orbitals, that can be a little confusing. I might ask you to be able to identify it just based on like the position and adding up the atomic superscripts, but in terms of writing out full configurations, we'll definitely be sticking to the first 5 periods. So yeah, and then just things to be mindful of. It's going to maybe take a minute to click. It can be a little bit tricky. But again, when you're looking at these, remember, think of the atomic number, they're the electrons, right? So like the first level that's filled, it's 1s2 because the S block can only hold, or the S suborbital can only hold up to 2 electrons, okay? So there's 2 here because that particular orbital, any orbital only holds 2, but the suborbital of S only holds up to 2. Okay, so only 2 electrons. If you look here in their P block, there are 6 elements across the P block. a p sublevel can hold up to 6 electrons. Okay, if we look at our D block, there's 10 here. A D sublevel can hold up to 10 electrons. Okay, for nickel, that D sublevel only held 8 because we only needed 8, but it could hold up to 10. Okay, so that's where those numbers are coming from the P, the S, the D, and the F blocks, okay? And just like on the bottom with our F blocks, they can hold up to 14, okay? So just something to think about, to mull over. I hope that these examples were helpful. Of course, if you need more help, I will be more than happy to help, and during office hours, after class, all that good stuff.